All right, so what I want to look at is this problem in the book for chapter 4, section 3, problem number 13. And it says find the indicated probabilities using the geometric distribution, the Poisson distribution, or the binomial distribution. Then determine if the events are unusual. If convenient, use the appropriate probability table or technology to find the probability. And the question says the mean number of births per minute in a country in a recent year was about 6. Find the probability that the number of births in any given minute is exactly 4, at least 4, or more than 4. Now, a good thing to study while you're studying these different probabilities is the summary table on page 219, which lists the criteria for the different probability distributions. Now, this one talks about particularly the number of births per minute. And you'll see this meets the definition of the Poisson distribution, where the experiment consists of counting a number of times, x times an event happens in a given interval. And our interval is a minute here. So with the Poisson distribution, this question is telling us we have a mean of 6. We'll come over here. We'll have a mean of 6 births per minute in any given year. Now, our formulae for the Poisson distribution is going to be the mean to the power of the variable we're looking for times the natural exponential, Euler's number, to the negative mean over the factorial of x. Now, this is a complicated calculation, and for a problem like this, we'd have to repeat this calculation over and over again. And so mathematicians recognized that, and they made some tables. And so what we're going to do is we're first going to look for the probability of 4. That's the linchpin number in this. And instead of plugging it into this formula and then in rounding, what we're going to do is we're going to use the table of values in the book. And so if you go to Appendix B in the book, on page A12, you get the Poisson distribution. And across the top in the columns, you have the mean. And so if we look at our mean of 6, we come down until we find our x value, which is 0.1339. And so for us, let me get this showing up on the browser here. There we go. So we have Appendix B, Table 3, the Poisson distribution. I try to find my mean, which is here at 6, and I come down to 4, which is 0.1339. So I'll come back here, and I can just write in this value, 0.1339. And that answers part A. Now part B says that we want at least 4. The word at least means that we have x has 4 or more. Now, x can be infinite. And to find the probability working my way from 4 all the way to infinity, well, I couldn't keep adding. At some point, the numbers get small enough that I stop adding. But what helps for us is we can look at this being 1 minus the probability of x less than 4. This is the complement of this space. And so we can add everything up to and not including 4. So we want to look at P0. Again, going to our column and grabbing P0, we get 0.0025 out of the table. We look at P1, the probability of just having one birth in that time, and we get 0.0149. We look at the probability of 2 births per minute, and we get 0.0446. And we look at the probability of 3 births per minute, and we get 0.0892. And so the probability of x being less than 4 is the sum of all the probabilities. It's the sum of all the probabilities where the probability value is less than 4. And so if I sum those together, I get 0.1512. But I want the probability of x being greater than 4. Well, my probability is 100% minus the things that won't fall into that range, or 0.8488. And so the probability that my my number of births are greater than or equal to 4 is about 85%, if we look at that. All right, and to go to the last part of this question, which says more than 4. And so for more than 4, we're going to change our probability here. I'm going to pull this down so we can see these. So C says the probability more than 4. So it doesn't include 4. This changes the complement calculation that we did here, where I want to include 4. Well, luckily I have this number here already, so I just need to add to the 0.1512 my probability of 4, which we did in part A. And that, with my handy calculator here, gives me 0.2851. And so my probability, so my probability of x being less than or equal to 4 is this. And so my probability of x being greater than 4 is 1 minus 0.2851. And that gives me a probability of 0.7149. The last question says, hey, are any of these probability events unusual? And 0.05 or lower is unusual. And all of these events have a greater probability than 0.05. So these would not be unusual values for probabilities.